So as you've heard, my name is Alexander. I work at one agency, and my assignment as a consultant is at BIMobject, where I work with .NET in the backend. We write .NET Core, and we work with Azure, basically. So that's my daily life. But I'm not here to talk to you about C#, of course. I'm here to talk to you about Rust instead. And there's different reasons for that, and you'll probably notice why, as it goes. So if we start with the slides, these are two. This is the mascot. He's called Ferris. I have some stickers for him laying around, so if you want one for your laptop, please grab one. And this is the official logo of Rust. Doesn't say that much, but if you ever see something around looking like this, you know there's Rust involved in it. So what is Rust then? We can talk about... I can talk about Rust all day. I can tell it in whatever way, but I thought we'd go directly to the Rust website and let them have their say about it. So Rust is a language empowering everyone to build reliable and efficient software. So yeah, that's a mouthful. It doesn't say much maybe, but what it does say is that it promises performance, reliability, and productivity. The performance is, I would say, one really cool thing about Rust. It helps you quite a lot to improve performance. There's even built-in benchmarks or benchmarkers, runners that you can run directly using the main tool. Reliability, as you will see, is the main thing. This is like the one thing that they should enlarge quite a lot. It's very, very robust. So one small thing to note there is one example is that Dropbox has one service that they built 2012. They haven't touched it since. It's still running. And that's written in Rust. So reliable, yes. Productivity, if you're sitting in any language where you have a garbage collector or where you have a nice, where the language helps you a lot, it might not be as productive as that, but from a low-level language, it's really productive. So if we go back to the slides, most people when they start with a language, they'll start searching for it. So I thought we'll do the same just to have a look. What will we get here? Wikipedia is the first thing we'll always see, basically. And yeah, what it says here, it's similar to C++. And I know there's one at least who's working with C++ in the audience, but so you might think that it looks quite the same. I would say from a C# developer's perspective, I would say it is, but I also think that even if I'm working with C#, I don't have a hard time working with Rust, despite it being a low-level language. Moving on. Since it is a low-level language, if you come from a language where I do, for example, where I have C# or Visual Basic actually before, and maybe if you're using TypeScript or JavaScript, you usually have a garbage collector. And most of the people working with it or with the language, they don't even think about that they have a garbage collector. It just takes care of everything for you. But as you work with Rust or C or C++, you usually need to think about your memory. With Rust, it's a bit different though, you will see. It is a bit different, but the compiler helps you so much. So memory isn't really an issue. But to know here, you have a very nice computer, motherboard with a CPU, RAM, and GPU. We are only going to talk about the RAM right now. In the RAM, you have a stack and a heap. So think of the stack as a pile of paper, basically, and the heap could be either a drawer where you put memory in, or you have in this case, I just made a bucket. So think of the stack as having lines to the bucket when you need larger amounts of memory. The stack can hold small stuff, which means basically things that don't grow. If you have an integer, you can have it on the stack, basically. If you want, you can, of course, put it in the heap, but there's yeah, it's used for the memory that could potentially grow. For example, strings and other bigger objects. So how does Rust handle this then? Rust has some fundamental rules that makes the whole language. And these rules are basically compiled from C and C++. So what they've done is they have looked at rules that you apply when you write C or you write C++ code, and then said, we'll take some ideas from here and build a language around it, basically. And who did this? It's actually Mozilla Firefox, or Mozilla, the maker of Mozilla Firefox. One of the guys there, he one day thought that, hey, we're writing Mozilla in C and it's hard, so we'll apply ownership and try to incorporate that with the C code. It didn't really work out very well, but then he thought he'd create a new language instead, basically. So this is taken directly from the Rust book, like their documentation, like any other language has. I will show you that later. So ownership is Rust's most unique feature, and it enables Rust to make memory safe. Rust to make memory safety guarantees without needing a garbage collector. So yeah, it's also quite a mouthful, but I'll show you what it means. So starting with the first set of rules, this will be the ownership model. I have my girlfriend. She thought I would make a nice picture of it, so I'm trying to illustrate it as if you had a book. So in this case, what we're doing here, in any other language, you would create your book, you would give the book away, and the method would do whatever it wants. And then you would think that you could use the book after. But in Rust, you have this model where you need to manage how you give that book away. So in the real world, when you have a book or a string or a object, you would basically say either I can give the thing away to you. That would mean that if I give it to you, you will walk away and I won't have access to it later. But I could also, of course, lend it away. But so if we look at the Rust way, if I give away the book and I try to access it later, Ferris will pop up and say, "Hey, you can't really do this because you've given the book away. How do you expect to use it again?" So what happens here instead of doing like this, you could clone the book, of course, if you'd want a copy of it, which would of course mean that you would have double. You will use double as much space in memory as you would if you would just lend it away. And lending it away, also called giving a pointer in other languages, you just use the and sign. So basically what it means is, what I'm doing here now instead is I have my book and I'm saying, hey, you can borrow the book, but when you're done, I will take it again. So you would still be sitting here thinking, okay, but why do I need to do this? This seems like a hassle. I always need to know what I need to do, or I always need to think about how I give stuff away. And yeah, it might be weird, but in Rust, instead of having a garbage collector, this you can think of as your garbage collector. The ending scope. Every time you end a scope, Rust will look at any kind of memory you have on your heap and the stack, and then delete it automatically for you. So instead of having a garbage collector doing it for you, you actually need to specify everywhere what you want to do with the memory. So what in this case, what if I wanted to lend the book and say, hey, you can edit my book for me and help me with this task. Then I would say, okay, I will give you the book and I will say that it's mutable in a mutable way. So this means that Rust also is very strict in the way it handles mutability, which means that you can't, if you create an object, unless you specify that the object should be touchable, it won't be. So the compiler will basically tell you, if I were to try to push a string into this book without having it mutable, the Ferris would pop up again, or the compiler would basically tell you, hey, you can't do this. You haven't specified that you want to edit the value. And this is really, really handy when you work with all of your code, the compiler will always help you with these kinds of occurrences. So you basically never have to think about it, or you do have to think about it, but there's so much help from the compiler that it comes naturally. It also makes me as a C# developer wonder how everything is handled in the background, because it feels like each time you do, like you would in any other language, you would create your book and then you would give it away and you would expect to use it again. Who is deleting it and when and why and where? So this is a really great way of learning how to handle your memory. So then now we know how to give a book away. We know how to lend the book away, and we also know how to give someone access to edit it. But what if I have multiple users? You have a question? We can take them after, if it's okay. Yeah. So what if you would have multiple readers? You would have a one single object that you'd want multiple readers of. Basically, if you have multi-threading or you're using async code, you would need to use something like what Rust calls a smart pointer. What this is basically a standard struct that will help you box things. So if I have this book and I want multiple readers to read this book, I have to put this in a box so that other readers can come to this box and read it. And once again, if I'd want multiple writers to it, then something could happen, of course, and most of people will it'll come quite fast, and that would be that you have multiple writers to the same point. And if someone reads and writes at the same time, you would have a deadlock. This is impossible with Rust unless you specify that you want to override it. So these boxes that you can put stuff in, they come in all different varieties. So one example is the reference counter, the RC. This is one where you basically have an object, you have multiple readers. When the readers are done, when there's no more readers, Rust will automatically delete that for you, which is really handy. This is nothing I will go down too much in code and show, but it's good to know that anytime you have a weird scenario or a scenario that isn't basic, it's almost always the case that you are going to need a smart pointer. And in the cases where you try to do your thing without a smart pointer, Rust will tell you, hey, you might need a smart pointer here, and you might need one of these. So it'll even help you to select one from the standard library. So now we know how to handle many readers and how to give things away. Another scenario that you have in Rust, which is really, really interesting, and I'm still having a bit hard time to grasp it, but it's good to know that it exists. It's mostly inferred in Rust. As you can see, you have let book string. This means that instead of me having to write string book and then make it a string, everything basically is inferred if possible. So Rust will only ask you to give it an actual type if it can't really figure it out by itself. So, and this is true for the same thing that I will show you here. This could be done in C# in the same way as any other language. I would create two books, and I want the book which is longest back. So I give the two books away, but I only give a reference to the books because I want a reference back after that, as I'm specifying here. After that, I'm checking who is the longest, and then I return it. And you don't see a return statement here, but that's because there's also no, I don't know the English word, semicolon. Yeah, semicolon. Yeah, thank you. There's no semicolon, which means return in Rust. So you can write as little as possible, and if you have a semicolon, it'll return the value. And of course, the compiler will scream at you if you miss it. So it's really hard not to put anything there. If I wanted to, I could write return, but that means that I would write a novel, and I'm not here to write a novel. I'm here to write code. No. But this is one way of doing it. And as you can see here, Rust is saying, hey, you're giving me two parameters, and I don't understand how or know for how long these two would live. So basically what it means is I have two books. what if book 2 would be deleted before I get the longest back? So I would basically say, here you have 2 books. One of the books will explode when you have it, and you will try to give me that book. That would crash the program. It wouldn't understand how to handle that. And in most other languages, if you would do this in Rust or sorry, in C# or Java or in any other language, they would just swallow it. It doesn't really matter because you have a garbage collector. You give away one of the values and you let the other one die and get eaten by the garbage collector. So this is the way that Rust wants us to handle it. And it looks, well, weird. But yeah, you need to add something called a lifetime specifier. So basically what you do is you give it a value. It's this tick, and then you can say, yeah, you can give it, I give it the name A today. And so I'm saying that, okay, I have a lifetime, just as I would have a generic type. And then I'm putting that lifetime and saying, these 2 books, they live for just as long. So you can be sure that they will live for just as long. So just bring me back something that lives that long, which is still maybe a little bit hard to understand. But if we do it like this, then what if I told you that I killed the book, and the longest here in this case is the book that I'm killing? So this would mean that I have my first book. I then create a whole new scope where I create a new book that is longer than the first one. And then, then as we know, the longest book will be returned. But it's also being killed. So down here, something, it won't live enough for long enough, so it will die. So this is one scenario where you could end up having to add these lifetime specifiers to tell Rust which one should live. And there's multiple. You can play around with this quite a lot and try to learn. I try to not have lifetime specifiers and instead use something called unsafe code. You basically tell Rust, do this, and it'll tell you, I can't help you. And you say, okay, doesn't matter. So as long as you find something that is unsafe in a Rust code base, always ask why, because that's the equivalent of writing C code. So yeah. And as a C# developer, I don't want to, I'd rather touch the thing that the compiler helps me with. So we've seen that. This is that example. Yeah. Is there any, okay, so should we have questions now? I think there should be, if there's anyone having any questions about the lifetime or the way of giving away books and handling all of this. Yeah. Yes, for the lifetime specifier. Yeah. Are you saying, hey, compiler, trust me, these will die at the same time, or are you telling the compilers, please make sure these live for the same time? Or is it a question, or? Yeah. So basically, what you're doing, you're telling it these 2. You are saying these 2 books, they will live for just as long. So that's fine. But if you try to use this, if I were to create a new book outside of this scope and try to use it, the compiler would say, hey, there's lifetime specifiers here, and these 2 books. So it can figure out that these 2 books won't live. So yeah, I'm still having a hard time to actually grasp everything here, but it's really good because, yeah, you have this compiler that tells you in every case where things don't go right. This function would work here, but not here, because exactly, they are not in the same scope. So basically, this longest method has the previous lifetime, but right here, the longest book, it will die before that one. So, and the compiler, as you can see, it has told me book 2 doesn't live long enough. So it can figure that out. As long as they are within the same scope, within the same, that's fine. But right now, they are not. One is, yeah, on the outside. So, anything more there? Otherwise, I'll move on. So, working with threads in Rust, is basically like working with threads in many other languages. You spawn a thread, which is from the std, you say thread and then spawn, and then you have this magical move thing. The move thing basically says, hey, I'm moving context. I'm switching to another car, basically. And what happens here is, in this case, I am printing a little bit, and I'm having, I'm letting it sleep for a bit, and then I'm printing it out here. Rink. Nothing really special here, but it's you can see that it's not that hard actually to spawn threads and actually work with them. And this is where we come into a place where many other languages are, they handle it in different ways, but this is directly from the Go book. Do not communicate by sharing memory. Instead, share memory by communicating. So instead of having a locker with books or a book that you have multiple readers of and writers of, you should instead have multiple people. You should instead have multiple people communicating to each other the information that they need, basically. So you should try to keep it one way at all times, and not many readers to the same point, but instead many creators and one reader. That's the best way. So you could think of it as they describe it in the Rust book as if you have a stream. You have a water stream where you have multiple people dropping things into the water, and it's okay for the other guy in the other end to pick them up. But it's not okay to have I don't know how to put that in the same analogy, but yeah, I will show you. Sorry. So this is the way that they want you to communicate and share data between threads. They want you to have a multiple producer, single consumer way of working. So you have multiple producers, yes, they write the books, and then they send it down the stream to the one who is going to read it. That's the best way of doing it. You won't have thread races, and you will have a safe code base. It's also maybe not enough in some cases, of course. There's always the other, when you have the other way, you need multiple readers, you need multiple writers. For example, an SQL database or a database overall, you will need multiple readers and writers. Rust can, of course, handle that. But if we have a look at this example, it's you have a transmitter, you have a receiver, we spawn a thread, it creates values, it waits for a bit, and then it sends the values. This expect, I'll come to a bit later, but basically it says send the values. After that, if something goes wrong, expect, and then it just gives me it just prints the values, basically. I'll come to it a little bit later. And then on the other side, I have the receiver. I receive the values, expect. Yeah, it's a bad wording for that, but basically what I'm saying is just trust it, and if something goes wrong, print this message. So it's kind of a try-catch, but still not. And then I'm printing the values. The other way around, if I were to do as many others maybe want to do it, I want to have one single source that I mutate quite a lot. So that means that I need 1, 2, 3, 4. I have at least 4 smart pointers in this one. I'm creating a counter with an arc. This arc counts references. After that, I'm putting my value on the heap because it needs to be on the heap for multiple stacks to reach that value. After that, I need to create my my list of threads, which is being specified later down here because it's being inferred. So what I'm doing here is for each, I'm creating a inner counter. I'm creating a new arc, which is cloning the outer one. You can, yeah, I can keep on talking here for quite a while, but it's much more complex. And the reason why it's complex is because the whole operation is quite complex. And if you wouldn't do this, if you would do as any other language, you might have a concurrency exception thrown, for example. That's a quite common JavaScript and C# exception. But this would actually make sure that you forcibly handle it. You lock the threads and you unlock and you push. And yeah. So that's two examples of how you could work with moving data between threads. So Rust is very, very strict, which in itself is really good. But it's also, it's like if it compiles, then it will work. The only thing that will be wrong is the logic that you have written. So if you have done something wrong, then Rust can't really help you. But it can help you with managing the memory and the safety of it all. So I was trying to not talk about the exception thing, but it's because there are no exceptions. Rust has no exceptions. It also has no null. So you have no nothing, basically. We instead in Rust, or I shouldn't say we, but the language itself has two ways of handling this, and it's the enums, result and option. Enums are a bit special in Rust. They can be filled with whatever object you want, and it's awesome. So basically, the result would be used in an I/O operation. So if I try to read a file, I would get a result back, which is either okay or it's an error, and that error will of course be why did it go wrong. And another one is the option, where I have a list or an array of objects, and I try to get number 3. Either it's none, which means there is no object here, or it's some, which is, okay, there is an object of this type. So here are some examples. Nothing we really need to dig too much into, but we can have a look at it a little bit. Use option up there is a really great example. It's just as I said, you have a vector. In this case, it's like a vector is an array. And then I'm saying I have let exist. I know this value exists, and it's a 5. And then nope, doesn't exist. So I'll get a none. And Rust even has, with these values, with enums, you are forced to take action on every case. So if you have an enum and you have multiple values in it, and you make a switch or a match, as they call it, and you don't fill out all the types it could be, then it won't compile, unless you specify a default case. So in here, it would actually, if I say sum1 and I match on this one, if it's a sum, print. Also, since I'm doing this, it won't compile. But it doesn't matter for this case. If I want to use the result, we have this sum path. And here I can take a file and open it. And after that, I want to use this magical syntax that is made exactly for these two cases, the option and the why am I getting a brain fart here? Result and option. So you can use something called if let, and then okay or sum val is equal to what I'm looking for. And if it's sum or okay, if it's okay, it will be within this scope. Else, yeah, quite logic. But it's wrapped around. But the makers of C# or makers of Rust, they were basically thinking, if I need to do this all the time, it's quite, I always want to have the sum value, but I never care about the none value. Why not create a faster way of handling that? So they basically came up with if let sum okay, or if let okay val is equal to whatever you're comparing to. That's how they do it. So it's a fast sugar syntax way to solve the problem. And then you would have the case where in the last one, where you, for example, you have a long stack down from your, let's say you have an API, you have a controller, and then you have everything down to the database, and somewhere it goes wrong. Then I need to handle all the cases in all steps, and yes and no. There is these other syntactical sugar ways where you can handle it, where you actually say, as long as you return the same value up. So if I wrap something in result and say it's an integer, or in this case it's a file. If I'm calling something within this which has the same signature, when I do file open, I will get a result file of type either file or error, which means that I can use the question mark. So I could basically have, if I want, instead of taking care of the cases everywhere, I can just say question mark, let it go up. so that the ones who take the value can handle the value instead. So you don't have to always take care of the exceptions, if you so will. You can just push them up to the next level. This is great if you're making a crate, as they call it, or a package that someone else is going to use, if you want them to handle the errors instead of yourself. Combined with that, of course, you have these two where you have syntactical sugar with it. There's also a lot of other syntactical sugars which are so amazing. Like the match statement that they use is superior, I would say. It's so good. You can do whatever you want in this match statement. You can even combine it with an if statement within the match. So you can filter on whatever you want in this magical match statement. Yeah, I've talked about that. It infers types. So once more, it's like if you create a new vector, you can just push anything into it. The first thing that will push in, the compiler will make sure that the rest of the stuff is of that type. So you never have to tell it what it is from the beginning. If you are into Lambda or our way of like functional programming, there's also a little bit of that in Rust, where you can have your array and you can create an iterator over it, and then you can filter, map, you can do whatever magical thing you would ever do with your arrays. You can map, there's everything you can do in link in C# or with Lodash in JavaScript, you can do here in basically the exact same way. Scopes, the syntax can be a bit different. There's always good or bad in that. That's a bit up to the person writing who thinks how it should look, but this is how Rust does it. Yeah, I will move on from there. It's the door. Yeah. For the ones working with languages who has classes and interfaces and all of this magical stuff where you arrange your code in ways that no one understands. You can do that here also, of course, if you want to. You can follow any pattern your heart desires, basically, if you want. So what's happening here is that I have a main function which has an array of animal, and that animal is a trait, which is basically the same thing as an interface in TypeScript, JavaScript, or C#, Java, whatever. You specify a function in that the inheritors should implement, and then they will do that, do your thing. And the reason why we have this and self is because of scope. You want to scope that it's for this method. It's not outside of anything. If I do this chicken, I want to be able to call this inner method. Otherwise, it could be basically any dummy. You could think of it as a static method in another language, where you just have a method somewhere and you can call it. Yeah. So yeah, we iterate over it and we let the animals do their thing. And once again, we use the iterator and the for each. One thing that should be noted here is that the for each and a lot of the functional ways of working with arrays are actually being optimized by the compiler as you compile. So if you try to compile something that you would be writing by hand, where you iterate over an array, Rust will do it better for you when it compiles, if you use the Lambda expressions or the functions. So it's really, really, really cool. Yeah, async programming, they have taken... yeah, it's pretty new actually. It's actually only like 3 or 4 months old, which is... I think it's even younger. It's really awesome. When it came out, everyone was so happy. So it has taken... Rust came out in 2010 or something like that as first appearance. It has taken them 9 years to create the most optimal async syntax or runtime that there is. So I have in the end, I have a video that I encourage everyone to look at or have a look at. It's a talk by a guy that works with the Rust team, and how they have created the most optimal way of doing async work. So yeah, there's not much to say there more than that. We have the async. You create an async method, and you await it, just as you would in other languages. Maybe in C# we say await before instead of after. So yeah. When working with any language, you always have a tool you work with. So if you have Node, for example, or you work with TypeScript and JavaScript, you use Node, NPM. If I use .NET, in my case, I use .NET, the .NET command. If you use the old one, I don't remember, use Visual Studio and no other tool in the whole world. It's only Visual Studio. That's the best tool ever, but it's not. Yeah, so basically, Cargo is your tool or your gateway into everything. It can publish, it can create, it can deploy, it can benchmark, it can create documentation for you automatically from your code. It can, it's a gateway into everything. And with Cargo, you usually use something like Visual Studio Code. Or you can use, as in my case, I use Rider, which is an abstraction of IntelliJ. You can also use, I think you can use Visual Studio also, but the best tool I would say is Visual Studio Code. And then you have two options. You have the Rust language server, which is built into the compiler when you download it. What it does is basically each time you write and then you save, it runs the compiler and tries to compile the code and figures out every error in your code for you, which is good, but it's also quite heavy. So there is a project right now which is called Rust Analyzers, which is, instead of using the compiler, it does it without the compiler. And it's really awesome. So it's either or, but if you want to try it out, it's like, yeah, download Visual Studio, or Visual Studio Code, add on Rust, and it'll be the top 3 of them. To be noted, if you want debugging like you would in C#, I know JavaScript developers usually console log, or maybe not. At my company they do. No, but if you want proper debugging, you can of course do that. In Windows, you need to use C or C++. You need to set that up. There are guides to how to do it. And in Linux or Mac, you use something called Code LLDB. So we've talked about, you've seen the rules, you've seen how Rust handles things, and I think that's basically the main rules. Let's talk about the makers. So I briefly mentioned that there are Mozilla Firefox, or Mozilla. The Mozilla Corporation is the guys who created the language, and they are the fathers of the language, and they keep track of it. But it's not one team; it's actually multiple teams. So if you go to the Rust website, you have this governance here, and this is where you can find different teams. So there's a lot of different teams working with different stuff, and these teams, they change around quite a lot. So the reason, for example, why async code took 9 years is because it started out as one team, then it became 5 teams, then it became 3 teams. So it's been moving quite a lot because it depends. People have different opinions and they want to solve it in different ways, and so working with Rust is quite, yeah, when you have a look at these guys are awesome. They make great stuff, and this is they are often part of the community. So if you have problems, and you can reach out to them in their forum or in Reddit if you so want. So they make all different kinds of tools, and we have, for example, the guys who make Cargo. They what they do is basically they are the top layer. They talk to the other teams and combine it. You also have other teams talking about, for example, I don't know if they have you have the language team, you have the WebAssembly team, you have the tools team. Yeah, there's many teams, but the cool thing here is that these teams has come up with the idea where in normally from the beginning, if you start a language, there's always this fear of what kind of tools can I use, what are there, what developer IDE should I use. Everything like that is handled by these DevTools teams. So they've, for example, if you want to use develop for Mac, they have created a tool for that. So if you want to have a template for Mac, you say cargo template, and then you use their template for Mac. Or if you want to do for WebAssembly, or if you want to do for anything. So they have created an atmosphere around your project. So whatever you want to work with, they have set up a base project for you and set up a way of working. So that's a little bit about the teams. Maybe too much, I don't know. You might be wondering why I'm saying Stack Overflow here 4 times, but it's actually because all of these years, 2019, most loved, dreaded language of all. And then same thing, 2018, most loved language, 2017. Yeah, it goes on. So it's been on top of all languages for so long, and it's basically because of the rules I just showed you, and because you have the compiler that helps you with those rules and force them in a very gentle way and helps you down to the row level. So there's multiple people loving this language, but it's still quite weird because when you look at companies using it, it's Microsoft, it's Google, it's Discord, it's Cloudflare, it's Mozilla, it's there's so many different companies, but they are all big. They're all not here in Malmö. But I also know that there's a lot of developers who are keen and really like this language, and they try to do stuff with it. And since it's cross-platform, it can actually be used everywhere. You can compile Rust for the web. You can compile it for mobile, any mobile. You can even compile it to its own operating system. There is, or it's not official, but there is a guy who has created a whole operating system using only Rust. And he just got the Rust compiler running on his own operating system written in Rust. So it's kind of cool. Lately, there was this, I saw this blog post about Discord moving away from Golang, moving to Rust, due to the reason that they had in their servers or in their background, they need to handle who has read messages, basically. So the notification that this message is read. There's so many calls happening there, and so much logic apparently, that they notice when the garbage collector kicks in, it's really, really heavy. So they chose to move that logic to Rust, and they have actually started moving basically all their logic to Rust for the reason that it helps you create the code without having a garbage collector, so you increase the performance. Yeah, I think that was basically it for my talk here. This was a meme that I was forced to have here, and it's yeah. This is basically what most of these companies are saying today. I should have used Rust from the beginning. So, yeah.